Good morning, everyone. Welcome again back to the KSR YouTube channel. We're finishing the engine for Mullet today. So finally got the parts that we needed, parts we were waiting for. Got a balancer, got an oil pan, the rocker rails, the rocker arms. I don't think we'll probably put it in the car today, but at least I hope to get it reassembled. So let's get to work. All right, so if you're wondering what I just did in the vise with the spring and the gauge and all that junk, I'm about to tell you. So what I was doing was checking the pressure that the valve has on it while it's closed, both at the installed height, which is when there's no lift on the cam, the valve is on its seat, and also at max lift, and finding out where the spring coil binds. When I talked to Texas Speed, they had given me a number for where to set the valve springs up at, and I was coming up a little bit tighter with the Cathedral Port Heads over the square port heads. So I had messaged them just to double check that we were still good, and while I was waiting for them to respond back, I went and double checked the springs, and just from what I know from building engines in the past, we had enough clearance. But while I was measuring that, they confirmed that we were all good on that. And I'll show you kind of the numbers we got here. So 1/800 is where they wanted me to set it up, and I had 160 pounds of force holding that valve shut. 178 is where they're actually setting up, and that's only a 5-pound difference, so not a big deal there. 1.18, because it's a 600 lift cam, we're at 460 pounds, and then we coil bind at 1.01 inches. And if you coil bind, that's a lot of bad stuff happens. You're fully mechanically locked up, and stuff gets bent, stuff breaks. You bend push rods. If it's got a super good push rod in it, it can, break valve springs. All that stuff we don't want to happen. So hopefully we're getting all this thing set up to where it'll give us a lot of service life, and we're gonna go out and go fast. So now that I know all of the valve springs checked between, there's about a 5 to 10 thousandths window of the valve spring setup height. So don't need any shims. Just gonna slam all the springs back on it. We'll bolt them on the engine. All right, so that last little bit, I was trying to find out exactly where top dead center was. And I do that so that I can verify that the timing that I'm commanding in the computer is exactly what the timing is in the actual engine once we're up and running. I've mentioned it in another one of my videos before, but this is actually how I go and do it. So I take just one quick way that I can do. I just take the factory cover for the cam sensor, pop it off. Got me a little pointer that I machined. I mean, you can do this with a belt sander. You just chuck this in a drill and hold it at an angle and get a nice little point on it. And I've marked where top dead center is on here, and this will tweak just a little bit. So what I'll do is I'll get this made and then paint it, and then I'll go back in there, and while I've still got a cylinder head off, I'll spin the motor and find out exactly where top dead center, and then I can tweak this. You know, I can tweak this probably 1/8 of an inch either way to get it exactly on top dead center when the pointer matches the top dead center mark on the balancer. So let's TIG weld this little sucker on there, and then we'll go back to the engine room. All right, while that's still warm, I'm gonna go spray a little paint on it so that I can dry it and get right back to work. All right, so here's the finished pointer. You can see I remark the balancer on the back half of the balancer just because I'm not sure, I don't want it to interfere with the belt. But you get the angle straight off the balancer, and it's pointing right at the mark. So now one of the first things we'll do after we get it fired up is we'll put an actual timing light on it, verify that everything matches, and then we're good to go. So normally all your studs just go in just finger tight. Yeah, see? And then that way all of your torque is in the nut and it pulls the studs evenly in the block. One little exception that I make is on the studs that are in the bottom of the cylinder head. So for those of you that do not know, this is a 6-bolt block, and the difference between a 6-bolt and a 4-bolt is obviously 2 bolts, but it's per cylinder. So a factory block doesn't have that hole, and it doesn't have this hole, so you only have 1, 2, 3, 4 bolts around each cylinder instead of 6. More bolts, more clamping, the better, the more power you can hold. So my little exception that I do for these in the bottom of the head, right at the very top of the threads, I put just a little dab of Loctite. I mean, just a little dab. All I'm trying to do is keep it stuck, because if these start to back out while you're trying to take the cylinder head off, sometimes there's not enough room to get the stud all the way out without fighting fighting all kinds of stuff. So I just put a little dab of Loctite on them, and so the Loctite is just on the very tip of the threads there. I actually put just a little torque on them with the T-handle so that they are locked in place. That's just to help with disassembly later down the road. And these head gaskets, if you saw me dropping the rings in, these are the Athena style gasket that SCE makes. I don't know if the little ridges will show up. Get something, but there's ridges in there that kind of put a little bit of a clamping, it bites the cylinder head, I guess you could say. We'll drop the cylinder head on, and then we'll flip it over and we'll do the other side. All right, so for the last pieces of the valve train, got some billet rocker rails, which some people use the cast ones. I prefer the billet ones. It seems to be a little more consistent height between the saddles than the cast ones. And then, you know, plus it's just a machined finish rather than like I've got a cast one here. You know, the cast ones, there could be a little bit of imperfection here and there, maybe in the saddles. I mean, it's cast rather than an actual machined piece. It's just my preference. Not everybody has that. And then we've also got some nice Texas Speed rockers with the bronze bushings. You can tell by the tip these are new rockers that have had bronze bushings put in them. So they sent me some push rods they think are going to be the right length. Let's check and see if they're right. Right, so that's got the 2 lifters on the base circle. Alright, feels like there's going to be a little bit of lash there, which is not what we want with a hydraulic roller. Yep, a little bit of lash. So this thing having, interestingly enough, it sounds like it's less on the exhaust side. So we may have 2 different length push rods in this motor. So depending on the lifter that is in the engine, it'll be after a different amount of preload. Let's see if I can show you this up close. All right, so we got you right in on top. So you can see that is the lash that I was talking about. And with a hydraulic roller, instead of it just being solid, you can see I can force it to go further. So there's the lash gone. So that's the hydraulic part that's normally taken up by oil pressure and the design of the lifter. So somewhere between there and just a slight amount of preload is what we're after. Now I'll double check with Texas Speed on my part number that I think I saw on the lifters, and then we'll get the correct amount of preload. And going off of that, it sounds like we're going to have a different length push rod in the intake and the exhaust, which is not uncommon, just to get the proper, the lifter in the proper amount of preload. So the way it goes with aftermarket stuff, sometimes you gotta modify stuff. Basically, this corner is interfering with the pickup. It's pushing the windage tray up where it's getting in the way of the pickup. So I'm gonna go try and modify this. All right, so you see I rounded that corner. Try to give us the clearance we need. And I'm going to just snug this up, and then I'll put some fresh Loctite on this bolt once I verify that it clears. All right, I have to go fabricate a little more. Gotcha. Another thing I discovered was that, ooh, that's fancy. I discovered that the oil pump pickup is too close to the bottom of the pan. I typically shoot for 3/8-ish, 3/8, maybe a little more. I'd rather be over a little. I'd rather be over 3/8 by a little bit than under 3/8 by a little bit. So the factory windage tray and pickup is not designed to work with this little spacer they put on it, which the spacer makes the windage tray clear all of the rod bolts as they come around, because with a larger stroke, it gets out further from the crankshaft center line, which means it gets in the way of the windage tray. Yeah, then I think I'm gonna need to shorten this at least 1/8 of an inch. So I'll have to get out there and get after this thing with a cutoff wheel and the TIG welder. I'm one of those guys that's big on trying to do things that prevent me from work, even if it requires a little bit of work. So I tape off the sump. So for when I'm drilling holes to, for the bungs. So I'm going to drill a hole here and here, because we got twin turbos coming for this thing, and for the oil drain backs. And there's going to be shrapnel everywhere. So I have multi-layer taped off the sump area so that nothing gets down in the sump, because there's all these little cracks and crevices, and I really don't want any aluminum shrapnel getting sucked up into the oil pump pickup and then going through the oil pump. And we're just trying to be safe with Cleetus's engine, and we don't want to have to send it back to Texas Speed for a problem that I could have avoided. So we'll go drill some holes, weld some bungs, and then we'll be bolting all this back together. Engine assembly lube, and we can also take some of that and coat it on the O-ring so that we don't damage the O-ring. Put some on the bore for the O-ring. And it should kind of wiggle itself right in there. All right, 5 and a fuzz under a half. 5 1/2, dead on the money. Oil pan is 5 7/8. That leaves me with the 3/8 that I was after. Math, it's so silly. All right, well, that wraps up the engine enough to put it in the car. Yes, I know it doesn't have push rods and rockers in it, but there's no sense in waiting to get the push rods, especially because this week is Christmas. So I'm gonna put the motor in the car, get the push rods on the way, and it's nothing to just put some push rods in it while the engine's already in the car. Put the intake on it just to verify that we'll have clearance for a steam port kit underneath the fuel rails. And I need to call Frankenstein about a stud kit to hold this thing down on the engine. So that's gonna wrap up this video. I gotta go race a car with a Christmas tree on it. So we'll see you guys in the next video.